Okay, so something else that I was getting some questions about was this calculating the error for sine or cosine as Taylor series. So let's do this example again. What does this say? It says for values of x. So actually we're looking for x. What is x or what is the range for x? Can I use sine x equals using these two terms with an error less than this value? So what are the x's if I use this and I want to have an error less than 3 to the negative 4. So basically what I'm trying to do is find the error in terms of x, then I impose this limitation, this value on the error, and that gives me a range for my x. So remember we said there are two ways of looking at this. First, let's write the Taylor series for sine of x. We know that the Taylor series has infinite number of terms, and it looks something like this. So 3 factorial is 6, which is what we have there. So this is the Taylor series. Now, what we're doing, we're cutting off here and only using terms before here. One way we can look at this series, so this is a series, right? This is a series. And also, let me fix this here. And also looking at it, we can see that we have a negative sign every other term. So this looks like an alternating series. So I can actually write this as an alternating series, saying that for x is smaller than 0 and greater and equal to 0, I have formulas. When x is greater or equal to 0, then I have the formula for Taylor series for sine, which is this. And when it's negative, then I would have the same thing, only a negative sign here, and I would have the absolute value of x. Because this one, in this case, x is positive in this case, I can actually say this is also the absolute value of x, because x and absolute value of x for positive x's are the same. So here I can say that this sine of x, the Taylor series, is an alternating series, and an, so this is an alternating series, and an is this. Now, if you remember, when we had an alternating series, we had a formula for calculating the error if we used an infinite number, a finite number of terms, right? We said if I use, let's say in this case, if I cut off here, how many terms of this alternating series am I using? Look here, I'm using one term, two terms. So I'm using two terms of this alternating series. Now we had a formula for this. We said if I use two terms, let's show it with S. If I use two terms, then what I get for the value of that infinite series using two terms minus the actual value when I use infinite number of terms, which is the actual value of that series, the absolute value is going to be less than the next term. So if I use these two terms, my error using these two terms is going to be less than the next term. So it's going to be less than a2 plus 1. I use two terms. The error is going to be less than a2 plus 1, which is a3. Now, what is this? This is the error, right? So I'm saying that the error for using only two terms instead of infinite number of terms for this alternating series is going to be less than a3. What is a3? A3 is this thing here. But remember, a was always positive, so this is the absolute value of x. Now, this is what I find for the error. And now in the question it says, what are the x's for which the error is less than this? So this is my error. If I want it to be less than this value, what are my x's? I should solve this thing here. So now all I need to do is find this inequality and find a range for x based on this. So this is what I have. I can take this 5 factorial to the other side. And the next step, I can find the root of this, and that gives me, so I'm going to take the fifth root of both sides of this equation, and I end up with this. 5 factorial is 120. Let me write it here. So I have 360 times 10 to the negative 4. This is the range of x for which, if I use this approximation for sine of x, I will have an error less than this value for this approximation for sine of x.